A hearty welcome to you on the Wow Info YouTube channel. Today, we're diving into a question that might have tickled your curiosity at some point. Why are oceans salty? When you think about the vast expanse of the ocean, one of its most distinctive features is its salty taste. But have you ever wondered how this came to be? The ocean is not just a large body of water. It's a vital part of our planet, teeming with life, influencing weather patterns, and even playing a key role in the carbon cycle. But what about its saltiness? Where does all that salt come from? Over the next several minutes, we're going to tour through the depths of this mystery, decoding the science behind the ocean's saltiness. So, buckle up and prepare for salty adventure. Stay tuned to learn more about this fascinating topic. So, where does all this salt come from? Our oceans are teeming with salt, but have you ever wondered about its origins? The saltiness of our oceans can be traced back to two primary sources: rivers and underwater volcanic activity. Rivers, our planet's natural conveyor belts, play a crucial role in transporting minerals from the land into the sea. As rainwater washes over the Earth's surface, it erodes rocks, picking up minuscule particles of various minerals in its journey. Among these minerals is salt, or more precisely, ions of sodium and chloride. These ions are carried by rivers and streams all the way to the ocean, contributing to its salinity. Over millions of years, this process of rivers transporting salt into the oceans has been consistent and relentless, leading to the accumulation of vast amounts of salt in our seas. But this isn't the whole story. The second major contributor to the salinity of the oceans is underwater volcanic activity. The Earth's crust beneath the ocean is dotted with numerous volcanoes and hydrothermal vents. When these underwater volcanoes erupt, they release a variety of minerals into the surrounding seawater. Among these minerals are, you guessed it, sodium and chloride ions. In addition to these, hydrothermal vents, which are like underwater hot springs, spew out superheated water rich in various minerals from deep within the Earth's crust. This mineral-laden water mixes with the seawater, adding to its salt content. This combination of salt transported from the land via rivers and minerals released by underwater volcanic activity and hydrothermal vents is what gives our oceans their characteristic saltiness. The oceans are not just large bodies of water, but complex systems with a life of their own. They are a testament to the interconnectedness of our planet's systems, from the highest mountain peaks to the deepest ocean trenches. Each element, each process, plays a part in shaping the world as we know it, including the very saltiness of our seas. Ever wondered how the ocean maintains its saltiness? Well, let's dive into the rhythm of the rain and the dance of evaporation, the two key factors that help preserve the ocean's distinctive tanginess. Rain, as you might know, is essentially distilled water. When it showers down on the ocean, it dilutes the salt content. Imagine pouring a glass of water into a bowl of soup. The taste of the soup would weaken, wouldn't it? In the same way, rainwater dilutes the ocean's saltiness. But if that were all that happened, our oceans would eventually turn into vast brackish pools. So, how does the ocean retain its saltiness? Enter evaporation. Evaporation, the process by which water transforms from a liquid to a gas, is a constant occurrence on the ocean's surface. As the sun beats down and warms the ocean, the surface water molecules gain energy, break free from their liquid state, and rise into the atmosphere as water vapor, leaving the salt behind. This means the salt gets more concentrated. It's like the reverse of our soup analogy. If you were to let the soup simmer for a while, the water would evaporate, leaving the soup dense and flavorful. Similarly, evaporation leaves the ocean saltier than before. However, the beauty of this process is the balance it creates. While rainwater dilutes the salt, evaporation concentrates it, maintaining a nearly constant salt concentration in the ocean. It's a delicate balance, a dance choreographed by nature. So here's the takeaway. The ocean's saltiness isn't just about the salt that's already there. It's a dynamic, ongoing process, a give and take between the land and sea, the sun and the rain. It's a testament to the intricate and delicate balances that make our planet a living, breathing entity. So, the cycle of rain and evaporation helps the ocean to maintain its characteristic taste. And now you know, the next time you dip your toes into the sea, you're stepping into a world shaped by the subtle interplay of rain and evaporation. But why aren't all water bodies salty like the ocean, you might ask? Well, it's because not all water bodies are created equal. Let's consider lakes and rivers. Unlike oceans, these bodies of water are continuously refreshed. This happens through processes like rain, underground springs, and melting snow, which add fresh water into these systems. This fresh water doesn't carry the same amount of minerals or salts as seawater. Of course, it's not that these freshwater bodies are completely devoid of salts. They do contain some, but in much lower quantities. And here's the interesting part. Much of the salt that does exist in lakes and rivers doesn't stay there. It's actually on a journey. Just like a leaf floating downstream, salts in rivers are often carried away, moving ever onward towards a larger body of water. This is what we call the drainage or outflow. Rivers, for instance, are like nature's highways for water. They collect the runoff from rain and snow, along with the dissolved salts and other minerals. These rivers then flow into the oceans, delivering their salty cargo. Lakes, on the other hand, have a slightly different story. Some lakes have outflows like rivers that carry away salts, but other lakes, known as endorheic lakes, have no outflow. Instead, they lose water through evaporation. In these lakes, the salts stay behind and can build up over time, making the water in these lakes often saltier than seawater. The Dead Sea is a perfect example of such a lake. This continuous cycle of replenishment and drainage helps maintain the balance of salts in lakes and rivers, keeping them much less salty compared to oceans. Every water body, from the smallest pond to the deepest ocean, has a unique story to tell about its salt content. It's a story shaped by geography, climate, and the endless cycle of water on our planet. So not all water bodies have the same fate as the ocean. Each has its own journey, its own cycle of refreshment and drainage, and its own salty or not so salty tale to tell. So that's the story behind the ocean's saltiness. We've traveled from the very origin of salt, where rivers carry dissolved minerals from the land into the ocean, to the delicate dance of rain and evaporation that helps maintain the ocean's salinity. Along the way, we've also uncovered the intriguing mystery of why not all water bodies share the ocean's salty secret. Each of these elements plays a vital role in creating the briny blueprint of our oceans, contributing to a vast, complex ecosystem that continues to captivate scientists and explorers alike. It's a testament to the intricate balance of nature and a reminder of how interconnected our world truly is. As we wrap up this journey, let's remember that the ocean story is still being written and there's so much more to discover. Thank you for joining us on this exploration. Don't forget to like, comment, and subscribe to the Wow Info YouTube channel for more fascinating insights.